Hello everyone, welcome to the today's Unequal problem. So today's Unequal problem is the longest unequal adjacent group subsequence second. So this is the advanced version of the yesterday's liquid POTD if you have solved it. Okay, trust me, this is the medium level problem, but it is not medium level, it is very easy level problem. If you have solved the problem named as longest increasing subsequence. Why I'm saying this? Because this problem is almost 100%, I would say 90% is similar to this problem only. If you just copy the code of this problem, paste it in this problem and just do some extra modification, you will be able to solve this problem within 5 minutes. Okay, so let's jump to the problem description first. What is the problem description? We have been given a two array, same words and groups, with both will have same length n, and one extra thing is given here, Hamming distance. So Hamming distance is basically first thing to both the strings between for which we have to find a Hamming distance should be same length, but the number of positions at which corresponding characters are different. It means suppose I have two string like ABC and I have BCD. So Hamming distance for this will be both are same? No. So +1. Are both same? No. +1. Are both same? No. +1. That is 3. So Hamming distance for both strings will be 3. So if you see other string, if I took AB and AC, so Hamming distance would be 1 here. Okay, because A and A are same, so we have to eliminate them. Correct? This is called Hamming distance. And we have to find longest subsequence, of course, from an array. But there are few conditions for it. What? First is a group of I and I plus 1 should not be equal. That is given. Second, this word of I and word of I plus 1 should be of equal length. And that is what, the prerequisite for Hamming distance as well. Correct? And their Hamming distance should be 1. It means that both the strings should be similar, but there should be one index where both characters in both strings are not similar. What I am saying is, suppose given me the string as BAB, BAB, and given me the word cab, if you see, Hamming distance for them is a 1. So this is the valid condition they are following. Second condition is group of this string, whatever the group is there, group of this string should not be equal to the group of this string. This is second requirement. And we have to return a array containing the word corresponding to the indices that are part of the subsequence, longest subsequence basically, and this is what we have to return. Okay, so let's see this with the help of one test case. Sorry, we have been given 3 words, BAB, DAB, CAB. Okay, and groups are given 1 to 1. So I will just write them here. This is my first string BAB, this is my second string DAB, this is my third string CAB. Okay, and groups are given 1, 2, 2. It means that this both cannot be the part of same subsequence because both strings are having same group. That is given. Suppose let's say yesterday we solved, right? Whatever comes first, take it. This is what we have given. But here today groups is not a binary array, so the greedy approach will not work over here. Okay, and if you see the constraint that group of I can be from 1 to n. And what is n here? N is basically the word of n. Okay, so it will be 1 to 1000 basically, because 1000 is a group length over given here. So gridded approach will not work, so we have to think some advanced solution for this. And advanced solution is nothing but I am pointing to the longest increasing subsequence solution only, because that is similar to this problem. So suppose I am taking this back. Okay, just tell me one thing, if only this string is my solution, then what is the length of my longest subsequence? 1, of course. Correct. Just tell me one thing, if this string is only solution for this problem, what is the longest subsequence length? 1. It means that each individual string has 1, 1, 1, because if they are part of the subsequence, they will contribute +1 length in the longest subsequence. That is something given. For example, this is my DP array. Okay, given me this 1, 1, 1. Initially, I have initialized this. So dp of I tell me, this dp will tell me the length of longest subsequence till ith index. This is what dp of I tell me. I would say not till I, at I index, at ith index, not till I. Okay, because there can be the case I minus 1 can be the longest than the dp of I. So at ith index, this is what we want to make sure. Okay, yeah. Now just tell me one thing, this BAB and this DAB, what is the Hamming distance? So if you see BAB, DAB, both are similar, I will remove them. If you see the difference character is count is 1, and what is the given condition here? The Hamming distance must be equal to 1. This is what they have given the the condition in order to part of the subsequence. So yeah, these are valid. So if I want to say that, isn't this dp of first index, if this is my 0, 1, second, should be the whatever the count is here plus 1, correct? So if you see here the count is 1, so 1 plus 1 2, so this will be removed and 2 will come here, correct? 2 will come here. If I come here now again, if I ask this and this, so if you say Hamming distance is again 1, because cab and bag only B and C difference is there, so Hamming distance is 1, so which is valid. And second condition, group should not be the equal, so group is 1, group is 2, so again this will become from 1 it will become 2. Why? This whatever the count is present at that index plus 1. Why plus 1? Because this is also going to be the part of longest subsequence, correct? And if you see my dp array is something looking now like this, 1, 2, 2. It means that 2 is the maximum longest length that I can achieve. And if you see, output length is also 2. But we don't have to return length, we have to return words. How will I get that? If you see, from where this 2 has been become, from here, right? So anyhow, if I maintain from where this index has come up with count, I can easily get the word output, right? How? Suppose I have another list which is maintaining my length, from which length this has been built, sorry my bad, index. So if you see, this 0th index has been built from none, right? Because it was having initial its own length, so it is minus 1 because it has not been built from any other previous index. This 2 has been built from previous, for this the previous element was 0th index, so I will keep 0th index here. For this 2 the previous element was 0th index again, so I will put 0th index here. So if you see, this index array will look something like this. So I can return either this index or this index as a solution, because anyone will work, because they have said we can return any of, if there are multiple answers, return any one of them. So if I just took this, so this shows me that I have to, the longest length would be 2, so I have to consider this index word, that is a first index. First index word is a DAB. So in my answer I would just say, I will just put DAB. Okay, now for this, what is the previous parent? So I will just say here 0 was the previous, so I will just say words of 0 is BAB, so I will just append BAB. For 0th index word, what is the previous parent? That is the minus 1, that is my base case where I have to stop. So minus 1 means there is no previous parent, so I will stop. Now I will just return the answer in reverse order. So if I reverse it, it will become BAB, DAB, and this is the solution for this. Cab is also valid solution if you start from here, because you have to return only one of them. So this is how you can solve this problem, right? Let me first show you the longest increasing subsequence, how it looks. So this is standard code of it. This is present on GFG, right? So if you see in this problem, what they are doing, they are using 2 loops over here, correct? Yeah, they are using 2 loops over here. One loops run from 1 to n. This is my outer loop. So if given, if this is my word list given to me like this, BAB, DAB and CAB, and if I am here, my I will be here. For this I will calculate from its previous strings, correct? So this is what will do the inner loop, that will run from 0th index to the ith index. This is what it is doing here. Now what is the case? first condition is that their group should not be equal. That is your first condition, right? So what will be your case? Here they are just, this is longest increasing subsequence. It means current element means this element should be greater than its previous element. This is what they are checking. But in our case we have different condition. What is the condition? First is that group of J I basically it should not be equal to the group of J. This is my first condition.
I didn't understand that.
And second condition is that their distance should be equal to 1. Hamming distance equal to 1. Then only we will do this. What we will do? We will say dp of I is equal to max of dp of I, because there can be the multiple answer for each index, or dp of j plus 1. dp of j plus 1. This is what I will do. And whenever I am saying if my dp of j plus 1 is greater than the dp of I, then what I will do, I will maintain other list, that is index. So at index of I will just put previous index, that is a j, and at last I will use this index. This is what I have to do. So same thing we have done here. Okay, let me jump you to the directly to code. Okay, so if you see, this is my function, helper function, to find the Hamming distance. It returns true if distance is equal to 1, and this is what our condition, right? Hamming distance should be 1, else it will return false. So if you see, first I am checking length. So for Hamming distance, length of both strings should be equal. If it is not equal, I am returning false. Else what I am doing, I am looping over their length. I am using the count variable. If character is not equal, I am incrementing the count. At last I am just checking whether count is equal to 1 or not, because Hamming distance should be equal to 1 only for the condition. Now this is my main function. In main function, what I have done, I have implemented the dp array, which is initialized with 1. Why? I told you, right? Every individual list contributes plus 1 point in the longest subsequence, because each individual string has length 1. Index size is -1. Index size means this will help me to build my final output array. So this index of I at in index will tell me its previous parent index, correct? And I have to run this until I found index equal to -1, and this is my condition here as well. Until my max index is not -1, in this my result array, just append the word of max index and update the max index equal to its previous parent, that is index of max index, correct? So see, logic is simple. I have also taken 2 loops. This loop is running from 1 to n. This loop is running till 0 to I. What is the first condition? Group of I and j should not be equal. Second, their Hamming distance condition should be valid. What is the Hamming distance condition? It should be 1, and this is what my function is doing here for the word of j and word of I. Then what I am checking, if my dp of j plus 1 is greater than I, that is current element, then I will update my dp of I with dp of j plus 1. Then I will just say, for my current element, I have taken it from my jth index parent. So index of I will be j, and at last I just want to know, okay, max index. What is the max index? So far I have found. So I will just say, if my dp of I is greater than dp of max index, whatever the max index I have found so far, I will just say max index equal to I. This is the I, okay? Why I am taking this max index? Because it will be easy for me to run this loop. If I don't update here, what I can do, I can run simply for loop for val in dp, correct? And I have to just find max index of maximum value present in dp. That will be my final list. That will be my final string of my longest subsequence. And from there I have to go to its previous parents. How will I go it? Using this index array, and this is what I am using here. I am going to previous until I reach to the -1, that is a no previous parent is present. And I will just reverse it, and I will return that result. So this is how you can solve this problem. This is very similar to the longest increase in subsequence. If you have solved it, I would recommend you first solve that type of the problem, LIS, longest increase in subsequence, then you will easily solve this problem. Only condition is different, else whole code is similar. Now let's analyze the time complexity. So time complexity would be, this is my big of n square, and if you see, this hamming distance will take big of n square into k, where k is the length of string. And if you see the constraint, the length of word of I is at max 10, which is a constant. So overall time complexity would be the big of n square. Space would be big of n, because we are using DP array, we are using index array, so big of n. So I hope you got this solution. See you in the next video with a very intuitive solution, very intuitive approaches. Till then, bye. Thank you.